So when we add vectors together, we said earlier, if we add two vectors, we stack them tail to tip. Let's say I've got a red vector like this, and a blue vector like this, and a yellow vector like this. If I stack these three tail to tip, I can get my resultant as a straight line going from the tail of the first one to the tip of the last one. So my resultant is equal to the sum of all of my vectors there, right? We talked about this earlier. But we can do this mathematically too. Check this out. So if my red vector, I'll name this V1 for vector 1, name this one V2 for vector 2, name this one V3 for vector 3, and I'll name this one VR for the resultant vector, just so that we know what I'm talking about. I could describe my red vector here as having this x component, Vx, and this y component, V1y, and V1x. I could describe this blue vector here as having this x component, V2x, and this y component, V2y. And I could describe this here yellow vector as having this x component, V3x, and this y component, V3y. So do you see visually how my resultant vector is literally just this amount of change in the x plus this amount of change in the x plus this amount of change in the x to get my total VRx, and then this amount of change in the y plus this amount of change in the y plus this amount of change in the y to get VRy. In other words, my final Vx is equal to the x components of all of the previous vectors I added together. My final Vy is equal to the y components of all of my previous vectors that I added together. So if V1x is 5, if V2x is 2, and V3x is 3, then Vrx is just going to be 5 plus 2 plus 3 for 10, right? All we're doing is we're adding together all of those changes to get the total. So we can say that our final x component is equal to the sum of all the x components, and our final y component is equal to the sum of all the y components. So basically now we can add any number of different vectors together and get the sum by just breaking all of them into components and adding them together. Very simple. Okay, so why don't you guys try it in this next example question? So please find the components of the resultant vector made from adding the following vectors together. Then find the magnitude and direction of that resultant vector. So go ahead and pause the video right now and try to solve this problem on your own, please. I've given you 4 vector components and their amounts. I would like for you to try to draw this. All right, so pause the video, please. I'll come back in a minute. Okay, welcome back. Let's go ahead and try to solve this problem. So here's my first vector, A. I gave you its x and y components. That's A, meaning this side here is AX. It's got a length of 8 newtons. This side here is AY. It's got a length of 6 newtons. B here, like this. BX is this length. It's got a length of 2 newtons. BY has a length of negative 3 newtons. It being negative, by the way, is just showing it's going in the negative y direction. We're assuming a classic Cartesian coordinate system where these two directions are positive and these two are negative, by the way. So any positive y component will go up, any negative y component will go down. All right, so C has a y component of 0 and an x component of 7. Sorry, that was B. Here's C. It's got a y component of 0 and an x component of 7 newtons. And D is like this. Got an x component and a y component. Our x component is negative 5. Our y component is negative 6. Okay, so this question's actually quite simple. What's my total x? It's just the sum of all the x's. So that's going to be 8 plus 2 plus 7 plus negative 5, which gives me 10, 17 minus 5 is 12 newtons. And then my sum of my y's, my total y component is going to be 6 plus negative 3 plus 0 plus negative 6 is going to equal negative 6 newtons. So the x and y components of this final vector that I've made, this one, from the tail of the first to the tip of the last, my x component has a length of 12 newtons. My y component has a length of 6 newtons. Okay, so there are the components. Now we want to find the magnitude and direction of this vector. Okay, so magnitude and direction means I want the length of this line for the magnitude. The direction means I want the length of this line D here, and I also want this angle theta. Okay, so we're going to have to solve this using trig in order to get the final pieces of this vector. Now that I've, oh, I'm sorry, this is negative 6. Now that I've done this, I need to be able to use trig to find my last two pieces. Okay, so first things first, how do we find this side D? And we could do this in the other order if you wanted to. You could do this either way. It really doesn't matter. I'm going to move down for some more space. So how do we find this side D? We're going to use the Pythagorean theorem. So Pythagorean theorem says a squared plus b squared equals c squared. A, b, and c are just your three sides. A and b are these two. C is your hypotenuse. Which one you call A and which one you call B does not matter. Okay, so I'm going to say 12 squared plus negative 6 squared equals c squared and solve that for c. 12 squared is 144. 6 squared is 36 equals c squared. That's 50, 80, 180 equals c squared. Square root of 180 is, ask a calculator, 13.4. C is about 13.4 newtons. So there's our length. I need a D up here, actually, so let's go ahead and make that into a D. So 13.4 newtons is the length of this side. Great. Now all you have to do is find the angle theta. So the angle theta is in a triangle now. We know all three sides. This side's 12, this side's 6, this side is 13.4. This side being negative 6 just shows that it's going down. Geometrically, you can't really have a negative triangle length. So this works fine. I also drew this theta really, really badly. This is really sloppy. Let me try that again. Is it like it's in this corner? That's better. Okay, so now we can find this theta using any of your favorite trig identities. You can use inverse, cosine, sine, or tangent to get this one. Basically, when you do the inverse, you get an angle from two sides. You plug in numbers to get an angle out of this function. So the function sine theta, or sine theta, cosine theta, or tangent theta will turn an angle into a number that you can work with. Doing the inverse of that will turn a number into an angle. So it'll take the ratio of your two sides and turn it back into an angle. So we could do any of the following functions for this. We could say theta equals the arc sine of opposite over hypotenuse, which is same as arc sine 6 over 13.4. We could say theta equals the arc cosine of adjacent over hypotenuse, which is the same as arc cosine of adjacent to that is 12. Hypotenuse is 13.4. Or we could say theta equals the arc tangent of opposite over adjacent, which is 6. Same as saying the arctangent of 6 over 12. Okay, so any of these three trig functions will give you the same thing. And you could write this also as sine to the negative first, cosine to the negative first, and tangent to the negative first. Your calculator might call it one or the other. So all three of these functions will give you the same thing for your angle if they're in, if your calculator's in degrees. So let's try, I'll just do arc sine. So just a moment. Theta is about 26.6 degrees. Okay, that is how we solve that problem. Good job.